Let me take a few minutes and go through the questions that you asked me to go over, the ones that you voted on most frequently yesterday. So I expected you would ask me about questions 1 and 2 and 3. So guys, flat screen televisions are advertised by their diagonal measurements. So in other words, this LG television is 65 inches diagonally. Remember, the diagonal of a right triangle is the longest side. So that's why manufacturers use that longest side of the right triangle to tell you how big the television is, because, if you will, it makes it seem bigger than it really is at some level. Because in this question, you have a limitation where you only want a length of 60 inches. So you need to find a height that will give you that widescreen dimension. So that's why I set up the proportion for you here. Widescreen televisions have a length to height ratio of 16:9. That's called the aspect ratio in technical terms. So if the length along the mantle is 60 inches, then in order to have an aspect ratio of 16:9, you have to find the length that finishes this proportion. If you cross multiply and solve, you get 33.75 inches. So here's the idea. Your television can have a maximum length of 60 inches according to your spouse, but to have a maximum length of 60 inches, this means that the maximum height is only 33.75 inches, and you can use that length and that height to find the diagonal. And the reason you need to find the diagonal is because the diagonal is how televisions are advertised. So you need to pick a television that meets the requirements of your diagonal. So that's why when you write about question number 2, this question is a right triangular model. So the largest diagonal length for a TV that will fit, you basically just need to find that diagonal by using the Pythagorean Theorem. So you need to show me the 33.75 squared. That's the height. You need to show me the length of your mantle, which is the 60 inches squared. So you need to tell me that you're taking the square root of that in order to get 68.8. So what this says is that if you don't want a television that's any longer than 60 inches, it's no more than 60 inches this way, that can be accommodated by diagonals that are essentially a maximum of 68.8 inches in length. So any television that has a diagonal that's less than 68.8 inches, it will fit. So the bottom line is you want to compare to the 68.8. The television you're interested in is 65 inches diagonally. That's less than the maximum diagonal length of 68.8 inches. So that LG TV that you have your eye on at the top of the page, that one will fit. So this question is about comparing the hypotenuses. You had to calculate the hypotenuse. The maximum length that you can have is 68.8 inches, but 65 inches is less than that. It's smaller than that, so it will fit. So this television, you could choose. On question number 3, you're working the other direction. So this introduces you to something called 16-inch on-center construction. So the studs, or the pieces of wood, if you will, inside of the walls of a residential house, very commonly the distance between those pieces of wood from the center of one stud to the other stud is 16 inches. That's called 16 inches on center. So, but if you account for the fact that there's a little bit of wood here and there's a little bit of wood here, that only leaves you about 14.5 inches of space between the studs. Now, it's important for strength that that stud makes a right angle with the base plate there. So 95.5 inches is a pretty typical length for a stud. So if you have this leg, and let's say you measure the hypotenuse to be 96 and 9/16 inches. If you square the two legs and add them together, if that's pretty close to the hypotenuse, or to the longest side squared, then that suggests that the Pythagorean model fits here. And it suggests that across from this longest side, you really do have a right angle. And a right angle is important because that gives you maximum strength here to hold up your wall and to hold up your load. So basically, all you have to do is show me that you're taking the legs and squaring them, getting me a value. So The longest side, if you square that, so understand the 9/16 of an inch, if you divide that, that's 0.5625 inches if you take 9 divided by 16. So if you square this, you get approximately 9,324.3 square inches. So notice these values are really close. They're off by less than 10 square inches. Because those are so close, the difference is really likely just measurement error. People can't measure perfectly. So because those are so close, the Pythagorean relationship looks like it applies. So what that means then, you have to conclude that across from the longest side, across from that diagonal length then, you really can conclude that you have a right angle. So you really can conclude that across from the diagonal of 96 and 9/16 inches, you really do have a right angle here. So this question is about using the Pythagorean theorem in reverse. So after that question, the next most commonly requested questions were 8, 11, 13, and 15 on the next page. So I like number 8. I was trying to get clever here. So notice it's a right triangle, but because these are both 14, it is also isosceles. That means this is a 45, 45, 90 triangle. So this length is 14 radical 2. My guess is that that's pretty easy, but what I was asking you for was the measure of the angle. That's a 45-degree angle. The two legs are the same. That's an isosceles right triangle. You've got a 45-degree angle. So let me skip over to question number 13. On question number 13, notice you've got a leg with a radical 3, and then here's the leg without the radical 3, and it's a right triangle. Guys, that is the pattern for the sides of a 30, 60, 90 triangle. I know then that this is a 30-degree angle, and this is a 60-degree angle, and this side's going to be 24. So x is the 60 degrees. Question number 11, you want to know your Pythagorean triples, or at least it will help you to know your Pythagorean triples. Those are 3, 4, 5. Let me see if I can write them here so you can see them. 5, 12, 13, 8, 15, 17, and then 7, 24, 25. So here you're trying to find the hypotenuse. So this is not a 30, 60, 90 or a 45, 45, 90 triangle because none of those angles are labeled. But look, I see the 5 here. I recognize the 5. And notice the 5 is on a leg. I'm not interested in the 5 being the hypotenuse. I'm interested in it being on a leg. So notice 5 divided by 2 is this leg. 12 divided by 2 gives you the 6. So that means the hypotenuse is 13 divided by 2. If you wanted to write that as 6.5, that's fine. Frankly, if you wanted to use the Pythagorean theorem, you could write this as 2.5. You could say 2.5 squared plus 6 squared equals x squared. You could solve it that way too. That would be fine. And essentially on number 15, that's what you have to do. You have to use the Pythagorean theorem. Be careful, the question mark is not 10. This is not a 3, 4, 5 Pythagorean triple where I've doubled it. If you double it, I agree that you get 6, 8, 10, but 10's the longest side. It would have to be the hypotenuse. And here the hypotenuse is an 8. So this is not a 45, 45 or a 30, 60, 90 triangle. None of those angles are marked. So you need to find the missing side by using the Pythagorean theorem. Oops. So in this case, you're going to say that x squared plus 6 squared makes 8 squared. So that's x squared plus 36 equals 64. So if you take the 64 and subtract the 36, that's going to leave you with 28. So if you take the square root of 28, that radical can be simplified. 28 is just 4 times 7, so you can write that as 2 radical 7. So that's the fully simplified answer. Frankly, I'd be happy if you got to the square root of the 28, but 2 radical 7 is the fully simplified answer. So proceeding on the next page, the questions that were most commonly requested, let's start with 17 and 18 and 19 and 20. Actually, 17 wasn't the one that was requested, but I needed to do 18. So the sine of A, remember SOHCAHTOA. That would be a good thing to write down on your test. SOHCAHTOA. So the sine is the opposite leg divided by the hypotenuse length. So from A, the sine is 24 over 25. So I need that ratio here in order to do question number 18. Because if you change that ratio into a decimal, 24 over 25 is 0.96. So what we're saying is the sine of A is 0.96. So if I use my table or my scientific calculator, if I use it backwards, I can look up in the sine column a ratio of 0.96. So in the sine column, if I look up a ratio of 0.96, so here's the sine column. The closest I can get to 0.96 is right here. Here's let's see if you can see it. There it is, 0.9613. That corresponds to the 74-degree angle, and that explains the answer that I put on the key. And it's an approximation, so I should use the approximately symbol. So in a question like 19 or 20, understand, in question number 19 rather, you can just use the table or your calculator to find these values. So like the tangent of 78, literally go to the tangent column, find the 78-degree angle. Here's the 78-degree angle. There's the sine, the cosine, and the tangent. The tangent is 4.7046. So that's all I was asking you to do there. Literally, you're just looking it up in the table. So question number 20, I'm really kind of fond of. So here's your 30, 60, 90 triangle model, and you're trying to explain why the cosine of 60 is 1/2. Actually, that's this question right up here. You could even look in the table. If you go to the 60, here's the sine ratio. The cosine ratio really is 1/2. Well, the 30, 60, 90 triangle helps us explain that. So understand, from the perspective of the 60-degree angle, cosine is the adjacent leg divided by the hypotenuse. So the cosine is x divided by 2x. Well, that x represents the length of a side. So those are positive numbers. So I can take this 1x, the 2x, I can just cancel the x's and get 1/2. So this explanation, why do you get 1/2? Literally because the leg, the adjacent leg, is 1/2 of the length of the hypotenuse. That's all you need to write. I believe I wrote something similar to that on my key. So in a 30, 60, 90 triangle, the adjacent leg to the 60 is always 1/2 of the hypotenuse. You could literally show me a little algebraic argument if you wanted to. So again, I just wanted to practice using the table. Here's a cosine question using the table in number 21. If you want to find the angle to the nearest degree, you need to take the point 9651, find that in the column of the table, and work backwards to give me the angle. So in the cosine column, point 9651, here's the cosine column. 0.9651, the closest that I can get to that in my table is 0.9659. That will correspond to 15 degrees. So the trig questions were asked for pretty frequently, so let me make sure that you know what the right pictures look like. So I will tell you the most important thing, once you've drawn the picture, live with the picture and write me an equation. So even if the picture's wrong, if the equation matches the picture, I can give you full credit for the equation. So if you write the equation wrong, well, at least solve the equation that you gave me, because then I can give you partial credit for the solving. So here, my ski run length is the diagonal length. It has to be a right triangle. My vertical drop, so up and down, that length is 1,100. So the angle of elevation would be right here. We don't use this angle here. This is the angle of depression. That angle is also 24 degrees, but this question was asked about the angle of elevation, so here it is. So in this question, the opposite leg is labeled, the hypotenuse is labeled, but the adjacent leg is not labeled. So this is a sine question. The sine from the perspective of that 24-degree angle is the 1,100 over the x. So you can find the sine of 24 using your calculator or using the table, and then you simply have to cross multiply that. Multiply the decimal to the x, multiply 1,100 to the 1. You have to cross multiply it in order to solve. And frankly, at this point, the most important thing is to make sure you understand the pictures. So here's the highway. The highway is actually the diagonal length that you would be driving on. So vertically, the highway rises 140 feet for every 2,000 feet of horizontal distance. So I was trying to help you by using the words horizontal and vertical to help you draw your right triangle. So the highway is the diagonal, and you're trying to find this angle of elevation. So the highway, the hypotenuse, is not included in this question. It's not labeled. So this has to be a tangent question. So the 140 over 2,000 is your tangent ratio. So I would turn that into a decimal and then use your table or your calculator backwards to find the angle to be 4 degrees. So in question number 24, here's where the lighthouse would be. Hopefully, if it's built well, it makes a right angle with the ground or the beach, and then we extend out in the ocean to the boat. So the angle of depression is not this angle inside of the triangle. It's this angle here outside of the triangle. It's the same as the angle of elevation. The height of the lighthouse is known to be 155 feet, so you can figure out how far away the boat is. That's this horizontal distance here. So again, in this question, the hypotenuse is not labeled. So using the opposite and the adjacent legs, this is again a tangent question. So the tangent from the 22-degree angle is 195. The opposite length divided by the x. Again, you find the tangent of 22 using your table, and you can cross multiply to actually get your length of about 483 feet. So question number 25, a square. You have 4 right angles, 4 sides that are the same, and I told you that the diagonal of the square is 10 inches. So label that as 10 inches, but the idea is you can use one of our mathematical models here. You can use a 45, 45, 90 triangle here to find the perimeter. So notice if the diagonal is 10, if this is a right angle, if it's a square, all 4 of these sides are the same. It makes this triangle an isosceles right triangle. So I know these are 45-degree angles. And here's my hypotenuse. So I can't see the radical 2 on the hypotenuse, but I can rewrite 10 as 5 times 2. And that 2 I can rewrite as radical 2 times radical 2. So then here's the radical that I expect to see on the hypotenuse. And here's the length then of each leg of the triangle. So each leg of the triangle is 5 radical 2, but that's also each side of the square. Each side of the square is 5 radical 2. So the perimeter is just 4 of those added together. I would just do 4 times 5 radical 2, and 4 times 5 makes 20 radical 2. So on questions 26 and 27 then, I wanted to take a little bit of time to actually do these questions directly. Let me find my blank page here. So there are multiple ways to do these questions. So I used trig to do these questions just for the practice. So hopefully the angle isn't too hard to find. If this is 90 and this is 27, if you take the 90 and the 27 and subtract those from 180 degrees, that gives you a 63-degree angle for the measure of angle B. And then, guys, you can find AB and AC however you want. So you can use the 63-degree angle. If you wanted to, you could use the 27-degree angle. It looks like on the key I used the 27-degree angle. So here, just to do it differently, I'll use the 63-degree angle. So let's start with AB. AB is the adjacent leg to the 63, and I know the hypotenuse. So you could write the cosine of 63 is equal to the length of AB over the 15. And then you can solve that. So if I use my table, the cosine of 63, it's 0.4540. That's AB over 15. So if I multiply both sides of that equation then by 15, that gives me my length for AB, which is approximately 6.8. So I'm just going to round that to 6.8. Now, the truth is, at this point in the question, if you know this length, even though you've rounded it, you could use the Pythagorean Theorem and say that AC squared plus 6.8 squared equals 15 squared. Now, that's not as accurate of a way to do it because you've already rounded this value once, then you're going to round a second time. I would not count off if you use the Pythagorean Theorem to do this because that's an appropriate mathematical model to use. A more accurate way to do it is just to keep using trig. So I'm going to use the sine ratio. So from the perspective of that 63, the AC is the opposite leg and the 15 is the hypotenuse. So I would do the sine of 63 is equal to AC, that length, divided by the hypotenuse. So again, using the table, using the 63-degree angle, the sine is 0.8910. So I can replace the sine of 63 with the 0.8910, and that equals the AC over 15. So if I just multiply both sides by 15, that will give me my length. So my length is about 13.4 if I round that to the nearest tenth. And there you go. So on the second question, it works very similarly. It's just the algebra is a little bit different. Again, if this is a 41-degree angle and a 90-degree angle, then the easiest thing to do is to find angle C. Angle C has to be a 39-degree angle if you take 90 and 51 away from 180. So it looks like that when I wrote my key, I used the 51-degree angle. Just to do things differently, I'll use the 39-degree angle here. So notice I already know this leg right here. For the 39, that's the adjacent leg. So I don't know the opposite leg. So opposite and adjacent, that would be tangent. So I could write the tangent from the perspective of the 39-degree angle. The tangent is the AB over the 8. I could do that. So the tangent of 39, let me look it up in the table here, is 0.8098. That equals AB over 8. So again, if you multiply both sides by 8, that will give you about 6.5. There's your length for AB. And again, this question is about using, this unit is about using right triangular models. Look, if you label this as 6.5, I agree. You could do the Pythagorean Theorem, 8 squared plus 6.5 squared equals the hypotenuse squared in order to find the hypotenuse length. Now understand that's not the most accurate method because you've already rounded the 6.5, so when you round a second time, you're going to have even more error. The more accurate way to do this is to use trig. As long as you show your work, I'm not going to take off for using a correct mathematical model, but to be more precise, the trig is the way to go. So this time I want to find the hypotenuse. So, and again, I'm not going to use the 6.5 in order to write my ratio because that's already a rounded value. Now, having said that, if you wrote and used the 39 and the 6.5 and the hypotenuse, if you showed me that that's the model you're using, I will take that. But the more accurate way to do this is to, again, use the 8 that was already given to you. So from the perspective of the 39-degree angle, the 8 is the adjacent leg, and I don't know the hypotenuse. So adjacent and hypotenuse, the hypotenuse is what I'm looking for. That's cosine. So I could do the cosine of a 39-degree angle. That is equal to the 8 divided by the hypotenuse, which is the BC. So the cosine of 39, I can look that up in my table, 0.7771. That equals 8 over BC. So you just have to be a little bit more careful with the algebra here. If you write this over 1 and cross multiply, the 0.7771 times BC, that equals the 8. So essentially you're just dividing by the 0.7771 in order to get your results. So the 8 divided by the 0.7771, that gives you your answer of just about 10.3. Again, what I'm trying to emphasize here is that there are multiple ways to do these questions. So the most important thing that you can do is label the model and show me the equations that you're using or you're writing in order to get your results. That's the best way that you can earn partial credit. Hope this has been helpful. Good luck on your test.